You are welcome back from break. Before we continue from where we stopped, let me remind you to please subscribe. It's just once. Subscribe, press or click the notification button so that you'll be informed when new video is released. Don't forget, and make sure you tell your friends about this channel. So far you are enjoying it. Let's continue from where we stopped. Now we come to another subheading, conversion of order basis to base 10. What do we mean by conversion of order basis to base 10? Don't forget that I explained to you at the beginning, under the first subheading, we considered that base 2, 3, 4, 5, 6, 7, 8, 9 are referred to as order bases. So anytime you are converting numbers from base 2, base 3, base 4, base 5, base 6, base 7, base 8, base 9 to base 10, there is a particular procedure which is uniform to all of them. The way you convert a number from base 2 to base 10 is the same procedure you embark on when you are to convert base 5 to base 10. It's the same protocol you observe to convert base 3 to base 10. Do you understand? Let's go and see how we do it. Convert 11101 base 2 to a denary number. What do we mean by a denary number? A denary number is a base 10 number. So that means we have to convert this number in base 2 to base 10. And what do? You just rewrite it as 1, 1, 1, 0, 1 base 2. Assign power to them from the back as 0, 1, 2, 3, 4. What do we mean by this? To convert this to base 10, take the first digit, which is 1, multiply by the base. If the base is 3, you will put the 3 there. If the base is 5, you put the 5 there. If the base is 9, you put the 9 there. Do you understand? So, raise to power you assign to it, to that digit, which is power 4. Raise to power 4 plus the next digit is 1. You use it to multiply the base in the operation. Raise to its own assigned power 3 plus the next digit is 1 times 2 raised to power 2 that is assigned to it plus 0 times 2 raised to power 1 that is assigned to it plus 1 times 2 raised to power 0 that is assigned to it. So 2 raised to power 4 is 16. 16 times 1 is 16 plus 2 raised to power 3 is 8. That is 2 times 2 times 2. 2 in 3 places. So 8 times 1 is 8 plus 2 raised to power 2 is 4. 4 times 1 is 4 plus 2 raised to power 1 is 2. 2 times 0 is 0 plus 2 raised to power 0 is 1. Anything raised to power 0 is 1. 35 raised to power 0 is 1. 1 billion raised to power 0 is 1. So 2 raised to power 0 is 1. 1 times 1 is 1. So 16 plus 8, that is 24. 24 plus 4, yes, that is 28. 28 plus 0 plus 1, that is 29. So that is 29 base 10. If you like, you can put the base 10. And if you don't put anything there, the fact that you don't put anything there means it is in base 10. And that is how to convert a number from order basis to base 10. Let's consider example 2. Convert 110001 base 2 to base 10. The same procedure, don't forget. After all, is from base 2. The first one also was from base 2. So we write 1, 1, 0, 0, 0, 1, 2. You assign power from the back from 0, 0, 1, 2, 3, 4, 5. Now, converting this to base 10, pick the first digit, 1 times the base. The base also here is 2. 2 raised to power the 5 assigned to it, plus 1 times 2 raised to power the 4 assigned to it. Now I want to show you something in case you are working in the objective. Even in theory, you are okay, you are covered with what I want to explain to you. Only you have to be very, very careful. Once you see 0 as part of the digits, you know that if you operate it, you are still going to get 0 as your answer. Then why troubling yourself? See what I will do. I will now write plus. I will now go to the next one that is not 0. I will write 1 times 2 raised to power. What's the power? 0. Once you skip the 0 in the digit, then you skip their power, the attached power up. You skip them as well. You now go to the next one and you operate that next one with its own assigned power. The assigned power of this last one is 0. 0. So that's why we use it. And it will make your work to be very smart, brief, straightforward, no time wasting. Even in theory, it is appreciated. And in objective, it is superb because it saves your time. So 2 raised to power 5 is 32. 32 times 1 is 32 plus 2 raised to power 4 is 16. 16 times 1 is 16 plus 2 raised to power 0 is 1. 1 times 1 is 1. So you had 32 and 1, that's 33. You now had 33 and 16. You have 9, you have 4. So you have 49 base 10. Or if you write just 49, you are okay. So, and that is how to convert that. Let's consider example 3. Convert 11210 base 3 to base 10. 11210 base 3, 0, 1, 2, 3, 4. So we pick 1 times, the base here is 3, raised to power 4, plus 1 times 3 raised to power 3, plus 2 times 3 raised to power 2, plus 1 times 3 raised to power 1. I may decide not to go for that 0 because 0 will give me 0. But let me include it so you confirm. Plus 0 times 3 raised to power 0. So 3 raised to power 4 is 81. 81 times 1 is 81 still. 3 raised to power 3 is 27. 27 times 1 is still 27. Plus 3 raised to power 2 is 9. 9 times 2 gives 18. Plus 3 raised to power 1 is 3. 3 times 1, that is 3. Plus 3 raised to power 0 is 1. Don't forget anything raised to power 0 is 1. That 1 times 0 still gives us 0. So you had 81 and 27 and 18 together. I come here, 81 plus 27 plus 21. You understand? 18 plus 3 is 21. So 1 plus 7 plus 1, that's 9. 8 plus 2, that's 10, plus 2, that is 12. So answer is 129. 129 base 10. So if you are very conversant with what we did under sub-heading 1, you will realize that the result we got in sub-heading 1 is what forms our question deliberately I pick them to form our question under this subheading 2, so that you can see for yourself that what goes up comes down. Example 4. Convert 324 base 5 to base 10. We write 324 base 5. We assign the power from the back 0, 1, 2. And this gives us 3 times the base 5 raised to the power 2 assigned to it, plus 2 times the base 5 raised to power 1, plus 4 times the base 5 raised to power 0. So we have 5 raised to power 2, which is 25. 25 times 3, that is 75, plus 5 raised to power 1 is 5. 5 times 2, that's 10, plus 5 raised to power 0 is 1. 1 times 4, that is 4. 75 plus 10, that is 85. 85 plus 4, that is 89 base 10. And that is it. That is where we are drawing the curtain on conversion of order bases to base 10. We come to the last aspect of conversion in number base as far as your level is concerned. That is conversion within order bases. You have learned how to convert from base 10 to order bases. You've learned how to convert from order bases to base 10. Now it is time to learn how to convert within order bases. When I say within order bases, I mean I have told you that order bases are from base 2, 3, up to 9, 10, if you use 11, 12, just with the exception of base 10, they are all order bases. So when you now convert from one of them to another still among them, then we consider conversion within order bases. So example number 1. Convert 101101 base 2 to an octal number. An octal number is a base 8 number. So when you are converting from base 2 is from order bases. You are now converting to base 8. Base 8 also is among the order bases. So that's why we say conversion within order bases. What is peculiar about this subheading? When you are converting here, it is very mandatory for you to convert this number given to you to base 10 first and foremost. Then you convert the result to the required base. In this case, the required base is base 8, octal. So let's convert this first to base 10. 101101 base 2. You assign the power here 0, 1, 2, 3, 4, 5. To save time, wherever I see 0 among the digits, I skip it. There's no foul play there if you don't make your own personal mistake. 1 times the base 2 raised to power 5 plus, this 0 carries power 4 and I want to skip it, so I skip the power 4 alongside with it. I go to the next one, which is 1. 1 times 2 raised to power 3 plus 1 times 2 raised to power 2. I skip the next 0, which carries power 1. So I now go to plus 1 times 2 raised to power 0. So which is 2 raised to power 5 is 32. 32 times 1 is 32. Plus 2 raised to power 3 is 8. 8 times 1 is 8. Plus 2 raised to power 2 is 4. 4 times 1 is 4. Plus 2 raised to power 0 is 1. 1 times 1 is 1. So we have 32 plus 8, that's 40. 40 plus 4 plus 1, that is 45. So that 45 is in base 10. That is a juncture. From that juncture, you convert it to the required base 8 octal. So you now write, therefore, 45 base 10 to base 8 will be, you write 45 divided by 8, because you are converting it to the base 8. So this now refers you to one of the previous subheading we have considered. 8 in 45, that is 5, remainder 5. Because 8 times 5 is 40. Subtracting the 40 from 45, you have the remainder 5. 8 in 5 is not possible. You write 0. You now repeat the same number on which there is impossibility. You repeat it down here as remainder. So pick it from the bottom as your answer. Therefore, the question 101101 base 2 is equal to 45 base 10, and it is equal to 55 base 8. And that is it. So the final answer is 55 base 8. That is how to convert within other bases. Example 2. Convert 102 base 3 to a binary number. What is a binary number? A number in base 2 is a binary number. Converting from base 3 to base 2 is within these other bases we are considering. So you first convert 102 base 3 to base 10. 0, 1, 2. So we have 1 times the base raised to power 2 plus, I skip this 0 because it will eventually give me 0. So I use 2 times 3 raised to power 0 assigned to it. So we have 3 raised to power 2, which is 9. 9 times 1 is 9 plus 3 raised to power 0 is 1. 1 times 2 is 2. Addition is 11 base 10. Therefore, 11 base 10 to base 2 is 11 divided by 2. 2 in 11, that is 5, remainder 1. 2 in 5, that is 2, remainder 1. 2 in 2 is 1, remainder 0. And 2 in 1 is not possible. So we put 0, we carry the same figure down here. So put your arrow up from the bottom, showing that, therefore, 102 base 3 is equal to 1011 base 2. And that is it. If you like, you write it straight away like this, that 102 base 3 is equal to this final answer, 1011 base 2. And if you like, you can link it with the middle answer as well. 102 base 3 equals 11 base 10, and it's equal to 1011 base 2. All the same. Let's consider example 3. Convert 301 base 5 to base 4. So we have 301, 0, 1, 2. 3 times 5. 5 is the base. 3 times 5 raised to power 2 plus 1 times 5 raised to power 0. You can see that I skipped the 0 at the middle. Why? If I trade with 0, the profit will be 0. So that's why I don't trade with it. So we have 5 raised to power 2, which is 25. 25 times 3, that's 75. Plus 5 raised to power 0 is 1. 1 times 1 is 1. So we have 76 base 10. We are now to convert this 76 base 10 to the required base. The required base here is base 4. So we have 76 base 10 to base 4 is, we write 76 divided by 4. So we have 4 in 7, that is 1. It remains 3. 4 in 36, that is 9. Because 4 times 9 is 36, remainder 0. 4 in 19, that is 4. Remainder what? Look at it. 4 times 4 is 16. Subtract 16 from 19. Remainder 3. 4 in 4 is 1. Remainder 0. 4 in 1 is not possible, so we put 0. Remainder, we repeat this figure 1. Then pick your answer from the bottom. We conclude. Therefore, 301 base 5 is equal to 1030 base 4. And that is the final answer. So that is it. We are going to draw the curtain on conversion within other bases here. I want to believe you have proper understanding of what I have taught you on this. Thank you.